because this can get pretty messy, but I'll try to take this as slow as possible while maintaining a pace that you can go with. So let's begin. So this is one of the definitions that I'll start with. I'll write pretty small in here. Let me know if you think it's too small, because I can change it. So the force of air resistance be equal to a constant times the velocity. This implies that F is directly proportional to the velocity. Force of air resistance. Can everyone see that? Or does everyone want to move here? Because I'm going to write really small. Fairly small.
Do you want to move? Yeah.
Because I want to write the grand derivation. Your derivation at the most grand.
Wait. Oh.
Yeah, it's okay. We can talk. This is...
Just to be weird, I'm just going to spell constant this way.
Can the phone see that? Yep, the phone can see that. Perfect.
So, yes, so this is what we have right now. And remember, this equation only works when the velocity, when it has a slower velocity, when it has a lower velocity. It doesn't work if it's really high speed, because you would have a different relationship. You would have a quadratic relationship. But as far as I'm concerned with the AP exam, this is the only type I've seen. But you can choose to do the other type on your own.
Would you say like high speed? Like what kind of high speed? Like
Really high speed.
like light?
Not that high. That would be relativity dumb. But within this one, to reach light, you can't have mass and you can't have surface area, so air resistance doesn't really matter anymore. But if you did have, you could have air resistance by the medium. Let's not talk about that right now. But high speed would probably be like, let's say, 100 meters per second, something like that. Something along those lines. I'll get back to you on that, on what the actual threshold is. So we have that definition. So that's just a definition. So what this is saying, if I do a diagram, mg and F goes the other way. And we'll define this one as a positive y direction, and up is negative y direction. Why do you think that's more convenient? Because we're going down. That's why having this as positive will be better. So why don't we write some of the equation? So what I'm going to do is that I'm going to derive to you the velocity first, the velocity function of an object experiencing air resistance. So I'm going to start with this definition. The sum of the forces is equal to mg minus F, and that is equal to ma. So that's kind of just like Newton's second law, if you've seen this in your law. And F, in this case, is defined as that. Now my question is, what happens when this equals to 0? What happens when the net force equals to 0? That means the object is not accelerating downward or upward. What is the term when we reach that speed?
Constant velocity. Or terminal
Velocity. So that means that when there's no more force, there's no more net force within the motion, that means it has reached terminal velocity. That means it's not going faster downward, or it's not slowing down anymore.
So it's basically just not accelerating?
They're not accelerating anymore. It's just going to the sky at that constant speed until it reaches the ground. So that's what happens when the force is equal to 0, where the net force is equal to 0. It does not experience any acceleration. So we set that equal to 0, and instead of labeling v, we say vt, for terminal velocity. And do you see that we can solve for vt in this case? bt, kbt is equal to mg. Therefore, bt is equal to mg over k. So did everyone see how we got to that? So, we're just going to have this as a definition. So why don't I label this as equation 1? Just for reference, we're not going to be using that right now. We're going to save that for later. So then now we're going to go back to this equation. MA equal to mg minus kdv. Now, remind me again of what is acceleration in this case. I want you to think, what is acceleration?
Oh, just acceleration in general?
Acceleration is the derivative of velocity with respect to time. So do you see that we can write m dv dt mg minus kv. And actually, just to make this more clear, I'm going to label this as vy because we're going in the y-axis. You don't need that, but I do that. Actually, you don't need that. Sorry. You don't do that. That's not needed at all. So let's move on. So then now, what we can actually do is take out the k in this case. Take out the k from this. So what happens? K becomes k mg over k minus v is equal to m dv dt. Now, what is this? What is this definition? That is terminal velocity from here. So now, by doing this manipulation, we've been able to make that appear in this case. So I'm going to start using a different color.
Wait, how did you get from
here?
mg minus, yeah.
You have mg minus kv. If I take out a k,
It's like divided.
you see I have to put a k
Oh,
down here to
oh.
cancel it out.
Oh, so you just factored out a k?
Yeah.
Mhm.
Okay.
I really like this color.
That is a really nice color.
So we're going to be using this then.
I think the phone can still see it. Can still see the brown color.
Yeah. So I'm going to replace this now with terminal velocity. Right. That's fairly magical. So then I want to do something with that now to make our lives easier. I'm going to multiply both sides by -1. So this becomes negative. You don't have to do this, but I find that doing this makes the whole thing easier. And you'll see why. And instead of writing it this way, you see that by having the negative, we can actually switch the order of this. So minus k, so instead of saying that, we can say v minus vt. So I just transfer that in here. Does everyone see that?
Why are we multiplying by negative?
It will make our lives easier pretty soon. Instead of suffering the more algebraic calculations later on. You don't have to, but so it becomes a v minus vt. So does everyone see how we got to that? So then now, what can we do to actually evaluate an integral angle? So separation of variables. So this is kind of pretty similar to what we did last week, but what I can do is take dt and multiply it to both sides of the equation. This cancels, so then we are left with minus m dv k v minus vt. And to solve this equation, I want to put like terms on the same side and then those constants on the other side. So it's going to be dv over v minus vt is equal to minus k over m vt. So does everyone see how we got to that?
Yes.
So this is actually why we multiply this by -1. When I start evaluating this integral, we're going to result into ln. I did not want to multiply a negative on the outside of that, so I did it earlier. Because you'll end up doing the same thing. So did everyone watch the video or you can- okay. So what you have to remember is the integral of 1 over x, dx, is equal to ln absolute value of x. That's a definition you have to remember too. So I'm not going to go, plus c. I'm not going to go into that much detail on why that is, but that is actually a given equation in your AP equation sheet. So they do give this. But once you're done with calculus, you won't need that. You'll just know it. You'll just know it. Why? So if I take the integral of this on both sides, what happens? You see that it becomes ln v, and then what you have to remember is we're going to do a definite integral from 0 to v and 0 to t. ln v minus vt plus c is going to 0 to v.
So why is it plus c now? If it's a definite number.
Well, I just want to formalize it.
Oh,
so,
okay.
so that people don't get too strung out because of the process. I want them to be really used to it. So does everyone know how to evaluate the definite integral? Or should I do a quick demonstration?
Quick demonstration.
Quick demonstration. So let's say we have 0 to 2 and we're evaluating 2x. 2x. What happens when I take the integral of 2x? It becomes x squared plus c.
Wait, I forgot how to do the integral.
So it's like the opposite.
you add 1.
Yeah,
So-
you add 1. So you add 1 to here, so 2x. Add 1 to here, since this is 1, 2.
Uh-huh.
And then do that to the bottom too.
Oh,
It's like the
okay.
exact
This cancels out.
opposite. Subtract one, put it down. Instead, you're gonna add one and divide.
So that's actually the formalized definition. X n plus 1 over n plus 1.
Whoa, I
And
like
they
that.
do give that to you in the AP equation sheet.
Oh,
They give you a lot of things in the AP equation sheet.
really? I read that last year.
But the problem is that they limit your time enough so that you don't have to really get that much. So, yeah. So to evaluate this, what I'm going to do is I'm going to plug in, let's say this is x, this is x. It's going to be 2 squared plus c minus 0 squared plus c. So it's going to be 4 plus c minus 0, so we just disregard that, and c minus c. So then we cancel that, so we're left with 4. So that's how you evaluate it. You plug in this number first to the whole function, to every x value in the function. Then subtract that from this, from that same function, and so and place every single value in
Oh.
0.
I'm gonna take a picture of it. Yes, send it to me.
So yeah, so that's how you evaluate definite integrals. And you'll be doing more practice with that in your math classes. But do you see how we got that?
We're already calc geniuses. Like, it's go quickly.
So you don't learn this till chapter 4.
Wait, hold up. Where'd you get the x squared plus c again?
X squared plus c is the
Oh,
integral of
integral.
2x. Because you do x 1 plus 1 over 1 plus 1.
Okay.
And that's just x squared. And then you plug in, and then you create two expressions in here, in which you plug in 2 in here, and the x squared in here, and then 0 in the x in here. And then from there you get 4. So is everyone clear on that?
I'm gonna write it down.
I'll let that sink in for a little bit.
Yeah.
And we're going to be using that quite a bit right now. Hopefully not as much. Not as intense. So, I guess we can move on slightly. So now that we have that, so we're just gonna leave it like that for now. And what is the integral of this? Minus kt minus k over m times t.
Because they're both constants, right?
Yeah, they're both constants. K constant, t. K constant and m is a constant since mass does not change in this case. So minus kt. And why do you think it's redundant to do? Why do you think it's redundant to do this? Why is that? Why don't we need to show that? Why is that pretty obvious?
For what?
So I was thinking of not placing this, but I wanted to see if you guys can see why we don't need this.
So we know where to start. Wait, what?
Why is this redundant?
Because aren't we already
Because if you do the same process in this case, we're just doing minus k m t
It's so obvious how they get it.
minus k m times 0. So that's redundant in this case, so we just place, so we can just take this off. I can see some confusion, but does everyone see why?
No.
Okay,
Okay, I can get it.
let's think of different ways to say
Okay.
this.
So here, so
So-
Okay, yeah.
you plug in T.
Collaborate for a little bit.
So you have, so let's plug the T in right here. So we'll have K over M times T, just plug in T. And now you want to subtract it from the bottom variable here. So then you'll just have B.
So,
So
do you understand
So
it?
yeah. Oh, okay. Yeah.
You understand it now?
Yeah.
Completely?
Thank you. Yeah.
Okay. Completely honest? Okay. I'm gonna trust that. So it's okay if I erase this now?
You took a picture, right?
Oh yeah, I took a picture.
Oh, the phone,
Yes.
the phone's all good too.
Yeah, so he's recording it, so you're gonna come back and delete the moments. Again and again and again. Then you can.
What is this, Inception?
Wait, when it's a live video, like, does it actually record and save it?
Yeah,
If I for some
saves
reason get
after.
the number one trending in here, I would be shocked.
I would be shocked because there's only one.
I'd be really shocked.
There's only one person subscribed to the chess account, and that's me.
I mean, if other people for some reason wanted to learn this, then
And plus, this video is longer than like 15 minutes already.
yeah, it's much longer.
Like this would have to be a Vsauce video to be trending at this point.
There's the person.
So, okay. So why don't we continue?
Just remember. that was all.
I can remove this now? Everyone is good with me removing this?
Yes. Yeah.
Okay. Let's continue. So what happens if I do the same process in here now? Becomes Ln. So I replace every v with another v again. Which seems pretty useless, but it's formal.
It makes sense.
And I replace every v now with 0. The c's simply cancel out. And what are we left with? We are left with Ln v minus vt minus ln negative vt. So going back to your rules of logarithms, what do you think can we do to that one?
You could divide your v minus vt over negative vt.
Yes. Don't worry, we're almost done with the first equation. Trust me, we're almost done with, I mean, once we get the first equation, then it's pretty simple for the other ones. Theorems become pretty easy. And since I don't like this negative being down here, I don't like that. I'm gonna switch it back up here. So what happens?
So it's gonna be vt minus v.
Uh-huh. There. So that looks pretty satisfying to me. So now we can move on. So I'll let everyone catch up first before we move on to one of the final steps. Oh, we actually only have a few more steps left, which is good.
Yeah.
So yeah. So I'm gonna give the chance to everyone to ask me questions now about what have you done so far, and what are we about to do.
So things just a little bit jazzy after you integrate it slowly.
Yeah. So everyone understands this portion.
Yes.
This portion.
Yes.
Okay.
Yeah, things seemed a bit simple in the round one. And then they got more
Yeah.
complicated. That's just the nature.
Yeah.
Okay, for the brown part, I'm cool, and then the end of the purple part, and then it just kind of got messy for me at the beginning.
In
So let me just look at it one more
Oh
time.
sure. Okay, look. We have plenty of time, so we're good for that.
yes.
Make sure that we have.
Oh no, I know.
Okay, guys. Okay.
I recorded chess tournament games like that.
Oh yeah, you recorded.
No, that one was on Instagram live, and it didn't record all of it because Instagram
right.
only limits it to 1 hour. So I just ended up
We were there for almost 2 hours.
I ended up deleting it because that was a failure. I got our game though, the semifinal one. That's probably my favorite game.
Wait, Luis, that's a 0, right?
Which
Yeah.
one?
No. The line, the integral. That's a 0.
This
Yeah.
one?
Yeah.
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 Oh yeah.
All of those
sorry.
are
That looked like that looked like a variable.
Yeah. 'cause
It looked
Well,
like an O, so
Surprisingly, it does actually pose a similarity to
Yeah.
the delta symbol, which is used for tensors, the Kronecker delta tensor.
Cause you put like a little squiggle on it, so I.
Yeah, if it looked like this, then I'd be slightly concerned already because we'd be talking about relativity.
That's
Okay.
what the rating test does.
wait, I have a question. So the integral of negative k over m t, like
This one.
what happened?
How did we
Why
do
is
that?
there a t there? Because it doesn't, when you take the integral, the
Well, 'cause
dt
the
just
thing-
go away?
The thing is that the variable that's being integrated is a t, even though it's not there. It's kind of like if you're integrating like a constant and it's based on the derivative
Okay,
of
no,
a
I get
variable,
that.
it'll become that variable. Sort of.
Okay, I know, I get that part. I'm just talking.
Yeah, conceptually it's weird. Because k and m are constants.
Because
So when you integrated that part that she's talking about,
Which one? This one?
yeah, I'm
did
talking
you just,
about that
like,
part itself. Like
you-
the t is still there. What
did you
happened?
just like leave? Did you just integrate the t
This
part
one?
because there's a derivative? Yeah.
Yeah.
Yeah, so integrated with
So
respect
then the
to
t
t.
just goes away.
And so basically
Okay, I
the
think I'm
negative.
getting confused by the
Notation?
equation that
So,
says the
which
d
one?
about, yeah, that one just goes away because of the equation. You know, it said that it's equal to, so then the dv just went
Oh,
away.
this one.
And then on the right side,
Wait.
it's the
Oh,
t
the thing
just
is,
stays there.
the reason that happens is that this one has this one subtracting to it. So that means even if I plug in 0, that's never gonna go away.
What?
Wait, what?
Wait, are you guys talking about
Okay,
the
so-
left side of the equation?
Actually, point out to me where it's happening.
Okay, so I'm kind
It's hard for me to figure out what you're asking too. So
Of integrating like a constant or something?
okay,
So
so
Because literally what this is right here, it's the same idea as like integrating a random number that's a constant
Yeah,
with
because
respect to any
integral of something, let's say-
variable.
Let's say you have a
So once you
constant.
integrate that ends up equaling 3x no matter what.
So yeah, this one changes
Yeah.
because it's a constant.
You-
I got
you
it
gotta
now.
wait.
So K and M
I
are
got it
constants, 'cause
now.
they never
Cool.
change throughout the entire time the object is
I
functioning. You have to
completely
remember,
understand this whole thing
all
now.
this work we're doing is
Thumbs up,
calculating
5 out of
based
5.
on an
I'm
object that's
good.
falling from the sky.
Uh-huh.
So K is a constant that never changes, M never changes, so this is literally this, you're looking at this the same way you're looking
I
at
feel
like a
smart.
number.
You know,
Sort of,
like,
if that makes more sense.
Yeah, that,
I don't
that
know.
makes
So
more sense.
what was your main concern?
I think they were confused with how the T just spontaneously appeared.
Oh, this
after
one.
integrated.
Okay, so when you have a constant, let's say K, let's just do K.
Yeah.
This is a constant, and M is a constant.
Yeah.
So if I integrate that, what is the integral of a constant?
The variable, right? Or the constant
Oh,
times
it's
the
because we haven't
variable.
seen an example of this.
Yeah.
So, do you see that x is 0 is equal to 1?
Uh-huh.
Or t0 is equal to 1? So any exponent to 0 is equal to 1.
Uh-huh.
So let's pretend that there's a t to the 0 in this case.
Uh-huh.
What is t to the 0 when you integrate that?
oh wait, this is okay. I'm at
Because
the very beginning when you're trying to explain, I got all confused. But we've done that all the time in calc, so yes, we've done that before.
Yeah.
Oh, yeah.
We do that all the time in calc. Okay, we're just
Well,
tired.
no, we didn't.
Yeah, we do it all the time.
No,
When
it
we
just
direct it.
That should have been the first
Yeah, it
example
just
that she
looks weird
showed
in
you.
physics. Yes, that's
Yeah.
that's
It's like first example.
Wait,
I would be
wait, this is
concerned
cheaper?
if that's not the first example.
Gwen, but okay, we've learned that. It's just that it looks different in physics.
Yeah, exactly.
Yeah, because
yeah.
physics
Okay.
does.
Physics doesn't.
There's a
use
lot more
numbers for
variables and
constants.
yes,
Yes.
Physics is
We
So
do
we're
love
good.
our variables,
we're
so
good.
everyone is good now.
Yeah.
We're up to this point and we understand everything.
Yeah.
Okay. So let's begin actually simplifying this into an actual equation.
This wasn't an actual equation before.
So does everyone remember the process of exponentiating?
What does that even mean?
Exponentiating. Oh, okay, so you're putting it.
Oh yeah, okay, yeah.
And everyone
yeah,
seen that?
yeah.
Okay,
Makes sense. I got it.
so we're gonna do that for this one. What happens if you do that for here?
It'll
like
just.
cancel.
Yeah, the
That one goes away?
cancels out.
And this one doesn't have anything to cancel, so we're just left with it.
With the absolute value still there though, right?
Doesn't matter anymore.
It doesn't. Oh, it doesn't matter at that point.
So the thing with that is, you should place absolute values.
That was only to
That
ensure
doesn't-
that the
Yeah,
log-
to ensure that that it doesn't have anything negative in here.
But like once that exponentiating thing happens, it's like okay, you never existed.
Yeah. Well, and also the thing with here is that the terminal velocity is the maximum velocity you reach, and velocity is any velocity you can have during that motion. So you know that since this is always higher than this one, then we're never gonna have a negative value. So
Okay.
that's just something.
That's
to
just a
keep in
fail
mind.
safe.
Yeah. I
And
mean
you-
that's just for to be more formal in terms of the mathematics. But
Wait, Luis, is it still divided by the the bottom one? Oh.
so yeah. So does everyone see how we got that?
Mm-hmm.
We're almost there. Trust me.
Yay.
Actually, trust me. We have 2 more steps. And we'll be done with the first equation.
Yay.
Does that mean there's more?
There's 2 more equations. We want acceleration and position, but this is the most important one. That's the most important one, I'm pretty sure. Because every AP exam from the 1970s, I could see them asking. I saw them asking this, so they could ask that again. So I just want. So I can have. So do you see that we can multiply VT to this side? Because what do I want in here? I want to isolate this equation because that tells us the velocity at any time period. then there's two more steps I can do. I can add v to both sides of the equation and subtract this to that side. So we'll have vt minus e minus vt e minus k over m times t. And that is equal to v. And since these are the same, then I can just say this.
You just factor it out. Wait, Louise, would it like look neater if it was like if the e to the negative km over t was just 1 over e to km over t, or is it just there's just there's nothing practical about changing it to that?
You can change it that way, but I don't really like that since that takes up more space.
Well, like conceptually speaking, does it
Yeah,
help
that's fine.
understanding the concept of it? or
Don't
not
forget the
really?
end parentheses.
Thank you. So,
So, is there like any conceptual benefit with changing it to having 1 over e?
I don't really see it matter. Doesn't matter. But this is actually more easier to look at.
Read good stuff.
So this is the first equation. So what does this tell you? It tells you that if you're given time, let's say, because this is a function of time, this is the only one that changes, is time. Terminal velocity that doesn't change, k over m doesn't change, only t changes. So vt, so if you're given time, you can determine any velocity of the motion that an object is following.
So,
no, you go first.
so like the K is like any constant, like what would that be?
They give it to you.
Oh.
Oh, what?
Constant of air resistance.
Oh, so like a spring like you know
Yeah.
how like it's kind of how like a spring constant has a
And they don't usually ask you to solve for it, they usually only ask you for the equation. So, they have this picky. They don't want to make any mistakes.
So all you need is the mass of an object
Mass,
and
constant through air, constant through the medium, and then t. And then the terminal velocity.
so since all of those are constants, like just once you know what the mass of that object is, you'll just know the velocity, pretty much, right?
No, this is, the thing with this is it's not constant, I don't remember, I think it's different for each object.
It's different. Oh, so it's a different like a coefficient of air resistance for each
Yeah,
object.
I don't remember it exactly, but I think it's different for each object. I have to look at that more, but yeah, so that's the important thing you need to know about this. So, did everyone see how we did all of this?
And this is all while the object is falling, right?
Yeah. So does everyone see how we got?
Oh,
Well,
so
that's-
so that pretty much means as more time passes, it'll get closer to terminal velocity, pretty much,
Yeah.
right? Very cool.
So, if you're really confused by this right now or anything like that, don't really worry about it too much. The most I've seen them do is to just
So, like on the AP test, would they want us to?
go through this whole thing.
Yeah.
Not as this extensive. Some of them are a little bit easier. So
So this would be like an FRQ.
yeah, this will be an FRQ. And what they do is that they don't ask you all of it at the same time. So this could actually be the whole question. So they could say, oh, derive the equation for terminal velocity, part A. Oh, now write the Newton's loss equation, part B. Oh, part C, write the differential equation and put an integral in it, part C. And then
And then find the actual velocity.
sometimes they don't even ask that. Sometimes that's a question. So, yeah.
Feel
So is everyone good with this? Anyone want to take a picture just in case?
feel like we should move it often.
This makes so much more sense hearing this for the second time.
Yeah, I kind of want to do it senior year, but
Well, now you have
moving on,
video, you
so-
can watch it over and over.
I could.
I just.
So, which one shall we do next? Acceleration or position?
Position.
Okay, we chose the harder one.
No.
Acceleration.
Oh, wait, why didn't you do the harder one later?
Yeah, let's do the harder one now.
Well, I kind of want to understand the
Actually,
easier stuff first.
I'll give you,
like
I'll
you
give
did-
you acceleration first, so that you get a break.
Yes,
Oh, that's true.
acceleration
You're
first.
I'm gonna give you a slight break. So
What
I'm
do you
gonna,
mean break? Like a
No, I mean like a
No,
slight
Unless if we
break
run
from
into
that.
anything else that we need,
So
you
it's
know,
gonna
like
be
that
less
one
intensive,
equation that
yes.
needed to be given to
I
us.
guess we
Next
should
activity is gonna be
slow
like
the
3
intensity
lines.
as,
Oh,
like,
so
a
we're doing the
blur.
easy
Cool,
one?
acceleration,
Just for
let's
some
go.
downtime.
I'm gonna erase this.
Cool.
Even though it's not really
Take a
downtime.
picture. Just kidding. I have it all written down.
Okay. I mean, then you have that. So,
Even if you didn't, the phone recorded it.
so
Wait, I gotta check if it's still recording.
oh my.
Don't worry, it's working. It's working. Yeah, it's
Luis,
working.
Are you gonna do all your like lecture stuff at the field trip? Yeah, you're gonna do like a little, since you're like the president of STEM Club, are you gonna do like a little?
Do they still
Wait,
need
so you guys
officers
have
for
a
STEM
meeting for the
club?
STEM club?
Do you still need officers for STEM club? I'll totally be
I think they need some like quit, so.
Oh,
Cool.
me and Yenny are making posters tonight
Sure.
for
yes,
STEM Club.
Thank you.
Okay,
Or-
when do we meet? Every Monday?
Every other Monday.
Oh.
So I mean,
Does anyone
Just
here
text me when
know
it's
or do
happening, okay?
Indian Trail?
No, I want to though.
No, I'm looking for some TV and film people to watch.
so acceleration is dv is equal to dt. So what do? We just take the derivative of this, and we're done.
Oh, cool.
We're gonna make this
Wait,
really
so
easy.
this is a continuation?
Yeah.
Oh, shit.
We're not. We're only deriving this equation because this is an equation not derived in EP physics. That's one or two. Everything else in this dynamics you should know by now. I think you should know when she starts dynamics. Or at least I can. It will be much easier than this. That's why I don't go into that much detail. And I think everyone knows how to take the derivative of this.
Mm-hmm.
So this is a constant, terminal velocity is a constant. So that becomes a 0. So we're just left with this. So I can take this out again, actually. I can take out minus Vt in here. Because Vt is a constant. And does everyone know the derivative of e to the x?
It's e to the x times the derivative of x.
Yes.
Right?
So they give this to you in your equation sheet
No.
because they give everything in your equation sheet for some reason.
I think it's because they just know you won't have time to read it. And
Wait,
it's
hold
just a
up.
factual.
Why'd you move the VT out again?
Which one?
So the derivative of VT is equal to 0.
Because that's a constant. And since this is a constant, I just took that out.
Okay.
Do you want me to show it a little more?
Yeah, a little more please.
I can tell.
So derivative of constants are 0.
So I'm gonna actually write the steps.
Yes.
Wait,
So I can distribute this derivative in there.
Oh, you
did you guys learn the product rule?
Yeah, that was on our quiz today.
That probably could have been why you took it out. That was super easy.
It's not gonna be that. So this is a constant.
Mm-hmm.
This goes away because it's 0. And this is a constant since you agreed with me.
Mm-hmm. Yeah, but isn't it like attached to the E?
No, it's just a multiply. It's multiplied together.
Oh,
So
sorry.
I can take it out.
Okay.
Oh, that's what you meant by taking it out.
Yeah.
Oh, okay. I thought you meant like you removed it from its existence.
It went to
Yeah.
I would have to
calculus
change the laws of the university to that.
land. It went to calculus land,
Lost.
as Ms. Witten says.
Yes, calculus space disappeared into that.
Calculus land.
My calculus dimension.
I wanted to say something, but I
Yeah.
didn't put the phone to record it.
So, here we go. So, if we're taking this with the derivative of t, so I'm going to show you something. d dx of e to the x squared, that is simply ex squared times the derivative of what's inside in there, which is 2x.
Ooh.
So, remember that? Remember that part?
That's just like a thing.
Yeah.
Okay.
So that's just a property you'll learn later on. So if we apply that to here, and we're taking it with respect to t, you see that's going to be minus dt, e negative k over m times t. And what is the derivative of minus k over m times t?
Wait, if it's constant. Oh, it would
So
just be
it's
t,
that.
wouldn't it?
And
The
then,
dt of minus k over m,
wouldn't it be minus K?
Yeah. minus k
Oh
over
yeah,
m.
minus k over m.
Okay, I'm just like,
But
wouldn't we
don't
just do
overthink
that?
this. Do not overthink this.
Yeah.
So,
This
minus-
is supposed to be the easy one. Do not overthink.
yes, do not overthink this.
You had one job.
So, I can make this positive because negative times negative is a positive. Oops. And we actually can refer to a definition from earlier. Bt is equal to mg over k. What happens when we have Bt? So we have Bt k over m. That is all equal to g.
That's
So acceleration is simply g e minus k over m times t. Ta-da! Simple as that.
That's it.
Yeah, that's it.
Wait, I have a quick question.
Yeah.
So when you got to deriving the e part, is it not supposed to be? Is it supposed to be negative or something?
Yeah.
Oh wait. Oh, but the negative times the negative.
Multiply it
Right.
with
Shoot.
So the derivatives, yeah, we got you this point. I hope.
Yes. Wait, but there was this one thing that I had a question
Yeah.
about.
Go for it.
Wait, hold on, let me remember it.
So we have our second equation. Yay. I do want you guys to do problems, so I think we still have time to do our job. I'm just gonna have to do it slightly faster.
Wait, what? How did we?
Actually, what if I actually leave that the last derivation to you guys as a exercising homework?
Okay.
And I can post the solution online tomorrow.
No.
No? Okay.
No, I think the phone needs it.
Okay.
No.
Yeah, I feel like we should do it together.
Yeah.
Okay.
Okay. Wait.
We're all in this together.
Or how about
How did it just?
Like do it together and
Where
if we
did
have
the G
practice
come
problems,
from?
we should like do it at home and then
Sure.
you could show us.
That's fine. So,
the G came from there?
Oh, I completely missed that part.
Yeah, me too.
I was-
Yeah,
I was just writing.
I
I'm
was
like,
just
no.
writing it down.
Oh, here, yeah, that was it. So why is the derivative of negative k over m times t just negative k over m? Because isn't it? I thought k over m was the constant. So.
yes, k over m is a constant, t is the variable.
Oh, okay.
So, it's kind of like
Yeah.
2x, derivative of 2x is just 2. This 2 is just a constant.
Yeah, sorry, just
Okay.
quiz today and like.
It's okay, I understand that.
See, at least there wasn't any product in this one.
I don't think I need to show product rule till circular.
Circular.
I don't think I even need to show that. Maybe not. When we do angular momentum.
Oh man.
Because I didn't show that last year.
Wait, what do you guys own in physics?
Oh, I'm
Dynamics.
not in physics.
Oh, you're not in
I'm not
She already took physics.
Oh, you guys already took
You already
physics.
took
Yeah, we
it.
already took physics.
Dynamics. Well, now they're in dynamics.
Now they do dynamics. Okay.
So we're actually going the same pace.
Are you guys taking the second class? this
I
year?
don't think I have enough space in my schedule.
Really? That's a crap one. Well, but you guys are juniors, right?
I don't think I have it for senior year anyway.
Oh, you got that far
Why?
too?
Because there's no way I'm skipping at the
So, is everyone good?
Oh yeah, that's
Is
true.
everyone good with this?
I know.
Okay.
Okay, I have everything down. I'm
Why
good.
don't we erase this? And just leave the 2 equations. So we have one more equation and I'm hoping it goes a little bit faster.
I like how there's still brown there.
Oh, Luce, I have an idea. So for this next one, since you were like thinking about us having an exercise, should we just try and guess?
Again.
Guess. Get some
That's a
check,
little bit-
guys. Let's get
No,
some
and then
check.
you'll just tell us if we're right or not.
Yes.
guess.
I think we'll take a little. I think that will take slightly more time than we just.
That will take.
Yeah.
That will take a lot, considerably more time than if we just do it.
Oh, no, what
So I'm gonna kind of run through it slightly faster this time. Is everyone okay with that?
Yeah.
Okay.
As long as I have enough time to write stuff down.
So V is equal to, and in this case, I'm gonna label position as Y. Because we're going in the Y axis, just because.
Oh, so we're still falling down.
Yeah, we're falling down still. We've been falling down since we started. Just kidding.
No, we're not gonna take that before.
Yeah. So, we have that. So, I'm gonna transfer dt to both sides, to this side. And I'm gonna take the integral. So this just becomes y. And what does this become to? Since dt is a constant, once again, I can take it out of the equation and move it outside. And I can also distribute the integral.
Oh, that's true.
And since this is both negative, I can just say plus. Is everyone good with that?
Is that say 1 dt?
Yeah.
Can I just put dt?
Yeah. dt is fine. I should remove that. So if that's the case, let's begin by evaluating them one by one. What would be this one? It would be t
Oh yeah.
plus this one. I don't think you guys have seen u substitution yet.
Yeah, I was thinking like, yeah, I think there's that substitution.
Like,
Should we just
integrals?
quickly? No, well, u substitution is one way of getting what you want when you're doing it. You should just show them.
Yeah, I know what you use.
You guys went over that?
Okay,
Well,
so
we did it in like math analysis.
why don't I do it really quickly?
It wasn't with like integrals and stuff, but I know.
U substitution. We're gonna use this example again. Why don't I model this as? Why don't I model? There. So what if you're evaluating this integral? That's pretty hard to evaluate because. So to set u substitution, we're going to try to generalize this to an e to the u function. We're going to substitute in u. In this case, u would be x squared. Du dx would be 2 to the x, 2x. Do you see that I can substitute du in that case in there? Because we can have du over 2x is equal to dx. So if I substitute that in there, instead of saying x squared, I'm going to say e to the u times du over 2x. What happens? We can cancel out the x's in there, and we are left with e to the u du 1/2 outside. And what is the integral of e to the u? E to the u. So our final integral is e to the u over 2.
Like you have to plug in u back.
Yeah, so when we plug in u back, it would be e x squared over 2. And if you're not convinced that that actually happened, it just happened right now, I'm going to take the derivative of e to the x squared over 2. If I take the derivative of that, it would be e x squared over 2, again, times 2 to the x, since that's the derivative of the inside. The 2 cancel out, and we are left with e x squared. Yeah.
Okay, let's do that one with the e this time.
So is everyone convinced of that now?
I like when you say I convinced you when I was like convinced you in the first place.
Yeah, so I can't really go on and explain this a little bit more, but I suggest watching Khan Academy and
Yeah,
substitution.
I feel like if I watched like the videos before this, I would have gotten
you
more
would.
time. Yeah. And have
Yeah, it actually does though, Ridges. So,
Well, that's because that's possible.
so now that I'm thinking about that, why don't I actually leave this for you guys to finish? I'll post the solution, and you can try it first on your own. Once you really understand, because I feel like there's not really a point. I don't know. For me to go on, I don't know. What do you guys want to do? Do you want to look at this on your own? Don't worry, I'll post a really detailed solution.
Yeah.
Trust me.
I'm fine. Are you fine with it? Are you guys fine with this?
So if I post a detailed solution, you guys would be fine with this. Because I feel like for you to really get the physical intuition of this, I really want you to know u substitution first. And this is probably the craziest derivation we're going to do. So this is the final equation. It's not too bad. If you guys want to take a picture.
Oh, which one?
Actually, I can write it in here.
That last one.
But you can kind of see how we're already getting this.
Yeah, I mean, it's the same variables, so I guess that's a good sign.
Actually, what would help you is to take the derivative of this and try to see if you can work backwards like that. That would be another thing. And don't worry, I'll really post the solutions. Trust me. I played through it. So, I don't know. Yeah. Last year I didn't even get to go over the derivative of I didn't even get to show them the acceleration.
No, I don't remember seeing.
And now they're starting the position equation. So are you guys okay with that?
I guess.
And if you do find this, you'll be very happy. You'll find it to be much more rewarding than me telling you how to do it.
Yeah.
You'll feel 100 times better.
I just need to get like the integral stuff
Yeah.
down.
So if you watch all the videos, this will all click really quickly.
Okay.
And those videos take you about 45 minutes.
It's okay. I
So
have.
that's less than your homework in your other classes.
Yeah.
So
Oh, yeah.
And you can do it when you lay down in bed before you go to sleep.
yeah, so you'll dream about it, and then the next morning you'll have an idea about it. Okay, that's how I thought about the buzzer circuit. Is that
Just watch it while
I
getting
watched
ready.
I watched the videos the day before, and then the moment I wake up, I had an idea for the design for the circuit. So just let
Wait.
you know.
Wait, are you talking about digital electronics?
Yeah, game. Here's the game that fast.
Oh, really? He's already getting ahead.
You already did the counters.
Oh, you did the counters already?
So,
Wait, it's already done, Luis?
oh, which one? No, not yet.
Oh, not
We have some practice
Oh,
problems.
it's in practice problems. Do those need to get recorded? Or not really?
You should.
We should. Okay,
Record it.
because I'm gonna shift it to the projector screen. Goodbye, board.
Yeah. So, oh right.
Wow.
This.
It's on my face.
So we have some practice in here. Yeah. So if you do this, you'll probably dream about it, but you won't remember your dream. But the moment you wake up, you'll just know how to do it. Just like that. Somehow. So which problem did I say it's for us to do? So just like always, we should have 10 multiple choice, and you'll begin to see why we're doing all of this, why we're spending all this time.
Are we gonna do an FRQ or?
Yeah, actually, why not I divide this to only 5 multiple choice, and then save the rest for an FRQ. So let's only do the ones I think that you'll really benefit from. So I think this you should know this from the PE physics already. So why don't we do 5? Just want to see, just testing.
Oh, the black pen. I only have a blue.
There's probably a pen in here that you can borrow. So try that for a little bit. So, does everyone have an answer? Does everyone have an answer? I don't know if I answered that already. So yeah, this kind of sees if you're and I haven't seen them ask this, so they could ask this this year. They did ask this in 1970s. So they're more likely to ask this this year.
So just to clarify, so when you have that diagram and the V vector is that just means it's at constant velocity or something? And then like the A is constant acceleration?
I can't say that.
Oh.
That would give away too much. So kind of think back to last week. So yeah, I'm just showing you why you actually went over things last week.
What's the answer?
Has everyone had the chance to try this? The answer is D.
Yay, I guessed right.
Do you see why? So velocity is always tangential in this case. So this is already wrong. This is already wrong. These are the only possible choices left.
Oh, it's tangential.
Okay.
Oh, I get it.
So when you're increasing a force this way, that means you're increasing the speed. The acceleration vector must slightly shift. That's why this one is not right, because if you place a force in here, you're creating acceleration in there. That's why it's wrong.
Towards the curve. So
And then this one is completely wrong because that does not even make sense.
yeah,
I was thinking like the thing was going on a circular path and then like the force moved it to like.
So is it pretty much just saying that in that diagram,
Acceleration
there's
vector.
tangential velocity and the acceleration and the force don't even go together?
or not exactly?
No,
Or
no,
not?
so it means that you're just pulling it this way.
So if the so if the force and the acceleration are going in opposite directions,
Then you're slowing it down.
you're
I mean,
slowing-
if the force is going against the velocity, that means that the vector will shift this way. So if you refer back to the notes from last week, I said something like, if you're speeding it up, and let's say you're pulling it this way, and you have a circle in here, that means your acceleration vector starts to shift this way. But if you're slowing it down, it starts to shift this way. So that's just something to remember again. We learned it all the time. Last week or 2 weeks ago. So why don't we try another problem? So yeah, so I suggest going through all of this on your own. Maybe a week by week practice until the AP exam. Then I think once you do that, you should be good. Why don't we try 30? Now you'll see why we do it. I know there's a lot of integrals right now, and all of them have integrals, but try to see how we can get there from earlier. So this is probably one of the levels that they're gonna ask you about that. So that's a little bit going overboard, actually. Does everyone have an answer, or has everyone had the chance to try it? I know we're kind of going fast, but I kind of want to introduce a little bit of the speed in here. Just the AP test does give you 45 minutes for 35 questions. So that's a little bit more than a minute per question. So the answer in here is A.
Yep.
Oh, yes.
Did not know that.
So you can see the lack of convincing. So we can work through this a little bit. So from earlier, you remember that we had mg minus f is equal to ma. So in this case, we can have mg minus kv is equal to dv dt m from earlier. So I can just transfer this to the other side. You have dt over m, and we have dv over mg minus kv, and we take the integral of both sides. That's it. That's A. It's like magic. Physics. Does everyone see this? Is everyone convinced of the answer? Convinced, okay. So, I think we have time to do. Okay, I like this question. I actually like this question. And I can definitely zoom that in a little bit more. overthink this right now.
It's kind of stupid. Why isn't it white different?
Oh,
So kind of when you're thinking about this problem, it's trying to assess if you understand centripetal acceleration. That's what it's trying to assess. Constant centripetal acceleration. I mean constant circular velocity. Has everyone had a chance to try it? The answer is B.
Yay. Wow, understand
Okay.
centripetal acceleration.
When is the object only gonna have centripetal acceleration?
Oh yeah, almost let me
Here and here.
Otherwise, constant velocity
Yeah.
means that acceleration is equal to 0. So centripetal acceleration is only an acceleration. So there's actually make sense?
Everyone is convinced? Let's do an FRQ. Actual first FRQ. So we're gonna do 2008. And if you don't finish this, I think I have the link where you can check your answer key and they actually break down how many points you get for each one. Why don't we try this whole thing? Parts A to E. And you get 15 minutes to do this.
It's for,
So you don't have to do this in 15 minutes right now, since you're just starting, but
plus it's for.
eventually you should work your way to doing this in 15 minutes. Or less. Yeah. And some hints that I can give you right now is that force of resistance is not K, it's minus VV in this time. So that's just another thing to look at. It's the same thing. So yeah, I'll send you the link of how this is. I think this time everyone out here are doing really well. So yeah.
Yay.
In comparison to the last previous predecessors, I think you did really well. Just saying.
Well,
You're hard.
I'm part of that predecessor. I agree.
We're also part of the movement, so.
Yeah.
Yeah.
So,
I mean,
where is that? Let me find it on the- Yeah. So, yeah, I think you guys will do really well in the AP test. I have no doubt about that. We're actually a quarter of the way already.
wait, how many
Yeah,
sessions
sure,
have we
we're
had?
actually a quarter of the way.
Quarter is pretty good within with the 2-3 lessons, right?
Huh?
Quarter is pretty good.
We're going to.
Yeah, 3 lessons, so.
I
Since
say
we have 12
should
lessons in
meet up
total.
during lunch
Nice.
one day to go over this stuff.
Is it easier after AP Physics?
Yes.
Yeah, honestly, I don't know how I would do this without.
AP Physics?
Sometimes I feel like some of this should be part of AP Physics too. But
Well, they cover new material in AP Physics too. They don't go back to kinematics and dynamics.
Yeah, AP Physics 2 does not cover.
Oh, I don't think they meant AP Physics 2, like just AP Physics as well.
Oh, you mean like AP Physics 1?
You
One
mean
and
AP
two?
Physics too,
Fine
because
then.
the whole bunch
That,
of
that
new
will not
stuff.
survive right now if I
They
start
will
doing
not
this at the same time.
Yeah. And since you guys are really motivated, I'm really happy about that. So I can already see how you're gonna do well. So
I'm glad we have so many girls now.
yeah,
And maybe
actually last
physics
time it
C.
was actually only boys in here. So
Yeah, only boys.
So yeah,
Me, Diego, Nate, who else?
Nathan and Thomas. A lot of them didn't really go that
Yeah,
much.
Nathan and Thomas as well.
But they will be here for AP Physics too, probably.
Hey, what date is
Oh,
it?
the AP Physics electromagnetism.
They said no.
They said no? They're not gonna take it?
It's not. That's okay.
They might change their mind as the time gets closer.
I think it's gonna be more solid by that time happening since
Or maybe they just
because
think,
they're seniors.
they also might be like, after going through it once, they might understand how to prepare on their own.
Yeah.
They might prepare on their own.
So, well, they said I asked them if they can take it. They said they're not because I
They
don't know.
will be admitted by then.
I guess seniors already.
They think they don't need it anymore.
Maybe it's
Yeah.
But Thomas thinks about physics degree.
Yeah. So I
Diego
don't
already
really know.
passed it, so he doesn't need it.
So I don't really know. Because even if I get 5 in that one, I have to retake it anyway. At most colleges.
Even if you get a 5
Yeah.
in APC?
Yeah. They said that APC doesn't teach it at high enough level. But the way I'm learning it right now, I'm learning it the way a university would teach it.
Uh-huh.
So if I take it, then it should be really easy.
Yeah, it will give you time to do your research on the subjects you
Yeah.
like. And
I
learn.
the extra time I gain from that, I should just use for research.
Still costs money to
Did
take
you
the
look
class.
at Andrew's paper? I did not look at the paper, I just transferred it to you right away. Did you see?
Oh yeah, the problem sets.
Yeah,
I'm gonna work on them probably this coming weekend.
to look at them.
They're not bad. They're not bad.
No,
They could have been worse, but they're not bad.
no, and this is what, the first lesson, right?
Yeah. And that's kind of like the third calculus, I think. I mean like the third physics. Because
Yeah,
that's special relativity and classical mechanics again. That's
Did he take
intermediate
it,
classical
he took
mechanics.
it in physics C both as well, right?
Yeah. So I think he was able to skip that.
Yeah.
So I think he's taking to third level third level physics, which would be possibly classical mechanics again, but with Lagrangian mechanics.
Oh, that's fun.
So those aren't bad either if you understand how to really make it work.
I cannot believe how far Luis went within 2 years. Is it 2 years, Luis?
In 2 years.
Of what?
Since he took, were you in the same classroom taking AP Physics 1?
No,
Well,
he was third period, I was fourth period.
Oh, okay. But the same year, right?
yeah.
Same year. And same term.
Oh yes, because Kenneth used to say who got the highest score. That's
Yeah.
probably Luis, right?
Yeah. Because I think it was Kenneth and Sang fighting for the top back then.
Yeah.
Man, they graduated.
But Zane is still here.
Who?
I feel like it's been so
Same.
long.
Wait, Luis, how do you have time for like all your homework plus like doing these extra?
He doesn't have a bedtime.
You
No,
know,
I
he
do
has,
sleep. I do
he
sleep.
schedules his time. Like
I
he
do
has,
time my schedule.
Like for me, once it's 9 o'clock, I'm forced to go to bed.
Really?
Yeah,
No, I mean I could finish this at 9, but
but
I could be doing more things.
Do you have time to go to bed, Luis, or not?
Yeah.
You do, parents?
They don't tell me when to go to bed. Because what happens is after 9 I kind of stop working.
What
That's
do you
kind of like
do
my free
after
time. I just watch TV the whole until 10.
Really? So you finish your homework by 9?
Yeah.
Really? And you had Franck last year?
Yeah.
oh, you have Franck right
I
now.
have Franck right now, and it's so much.
It is way too much.
It does get quite a bit, especially in the end. I do have to say that.
No, it was a bit much since
Because
the
in the end, I
start.
didn't even finish the last 5 chapters. I could not physically finish the last
Which
5
class
chapters.
is it?
AP is history.
English.
So, I mean, it didn't really matter in the long run in terms of the AP test. The last 5 chapters didn't matter at all. So, you should be okay. Yeah, just.
She still makes you read a chapter a day, huh?
No.
Like a
it's
chapter
2
every 2
chapters
days?
a week.
Yeah, 2 chapters a week.
Oh, she got.
She starts with that, and then in the end it becomes 1 a day.
Really?
Yeah.
In the end, but I think you have more time since you
Oh yeah.
actually have more time.
It's just like she gives us a lot of unnecessary like graphic organizers and
No,
stuff.
that's actually helps. So,
Oh really?
and
Will it help? They can do the work right now so that you can use it to review right before the AP exam.
yeah.
Yeah.
So yeah. So for me, since I took it the spring term, which was very helpful, I didn't really have to review it anymore. But if I had taken it in the fall term,
I
I
took
would
it
have
in.
had to review quite a bit.
I took it in the fall term.
So all my schedule actually worked out. So has everyone had a chance to try this?
Oh, Luis.
Or
Louis, should I still record this? This is at
Yeah.
76 minutes.
6 Yeah, I think we're done.
We're done. We're done with
Well,
this
I mean, they can still keep it like this.
Okay, but like, is this section of the class, like doing the RFQ, would you want that to be recorded?
No, we don't have to.
Okay. Goodbye, stream.